Yeah, my name's John Corcoran. I work for Morgan Sindall. I have done for over 20 years, specialise in tunnelling. I'm currently site manager on the site at Hammersmith on Tideway West. And I first got involved with tarmac when we were looking to do the secondary lining for our 300-metre connection tunnel. This is the first section of secondary lining on the whole of the Tideway project. And I think we poured just under 2,000 cube. I was particularly keen to get this right because I spent several years on the Lee Tunnel. We poured over 50,000 cube of concrete there, doing the secondary line in there, and it didn't go perfectly. There were some problems. One of them, not least, was inconsistency in the batching of concrete. So I had a list of things I wanted to put right before we started secondary lining here at Hammersmith. And one of the key elements there was getting a consistent supply of concrete for a highly technical mix. We'd started using a different supplier here at Hammersmith and had some problems. We went through a fairly rigorous laboratory testing procedure to try and get our mix right. Several key elements on the mix, really, because we were doing what's called a 4-round concrete pour, 6-metre long shutter, and the concrete needs to be highly fluid to give us the right finish, but it also needs to gain strength so you can strike your shutter within 9 hours, which is very demanding on the concrete, and it also needs to be consistent. So the supply of concrete, delivery of concrete needs to be consistent. And for our shutter, it was just over 30 cube of concrete. So you don't want to start pouring that shutter and then find that you've got a bad batch of concrete on the way and you're going to have to stop your pour, cancel it, or delay it, where you potentially get a cold joint. Once you get a cold joint, you've got a problem then, because the tunnel needs to act both in compression and in internally it can be under pressure as well. So, and I'm talking here from bad experiences at Lee Tunnel, where we had exactly that on some of the pours. We also had concrete turning up that wasn't of the right flow characteristics. And the shutters there were a lot longer. So, I was highly motivated. We went through the lab trials. I think we went to 5 ready-mix companies. We did a full suite of lab trials. We whittled it down to 1 or 2 potential suppliers. And then we did full-scale trials. And the other thing I haven't mentioned is we were pumping up to 300 meters long to cast these linings. So there was 2 in the running, full-scale pump trials. We used Putzmeister 2190 pump with 300 meters of pump line in our trial section. And all the time we were gauging not only the concrete supply, but also the client, the people who were supplying us the concrete. Were they interested in us? Did they want to work? Did they react to what we said? And it was touch and go between 2, and we selected tarmac. One of the first things we did then in conjunction with the client was to audit the batcher. And I think this is where I started really to warm to tarmac, but be impressed by tarmac. So I think about 8 of us went to visit the batcher at Westbourne Park. It's called the Paddington Batcher. And from the moment we turned up, we were made to feel important. I think tarmac had everybody there. They had the project manager there. They had the people from who supplied the batcher, Lever. They had the overall plant manager for all of the batchers in London. And I felt like we could have spent all day there and they were still giving us the time. So that was great. But then I started looking around, and I've often said it that the batcher resembled a spaceship. Covered aggregate areas, real-time moisture probes coming into the mixing bowl, all the things that we hadn't had on the last job, which made my job difficult. And these highly fluid mixes, they're so sensitive to moisture content. It's not good enough doing a moisture content in the morning on aggregates that are out in the open, expecting that to last all day if you get rain. So all looking good. first pour we did, to say, was just under 2,000 cube in total. So the way it worked, we were trying to get 5 pours a week. We wanted to pour around 1 o'clock, 6-meter shutter, come in the next morning, strike, move it forward, reset, cast. So we spoke a lot with Tarmac on what I wanted. And I'm talking more on the production side here rather than the development of the mix. That was all going on in parallel. Again, very reactive. I found Tarmac. And I was more interested in the end product that did what I wanted it to do. I think the first day, the first couple of loads were rejected. The moisture low characteristics weren't quite right. We still poured that day. And then from then on, it was like clockwork. 1 o'clock every day. Wagons used to turn up. It was 4 wagons. And to say, I don't think we rejected any loads after that. The flow characteristics, I think it was around 600 mil plus or minus 50 mil, give or take a little bit. And every day it was on the button. We had to skip it down the shaft, and then we pumped up to 300 meters. We started at the far end of our tunnel, and then every day we'd move the shutter 5 meters forward, shutter, pour again, strike, pour again, pour again. And it was like clockwork. All the frustrations and problems I had on the previous tunnel, where you were never relaxed until you finished pouring your concrete, they were gone with Tarmac. And to such an extent that not only did we decide to use Tarmac for the tunnel secondary lining, but also we changed our supplier to Tarmac for our civils mix. We're doing a lot of concrete in here, a lot of complex underground structures that we have to do at Hammersmith. And we went through the design development process again for the mix, because we'd seen what good looked like in terms of concrete supply. It took 3 months. That's what it takes with Tideway to get a design approved, with the trials, testing, full-scale trials, then the day strength test, and aggregate testing. There's a whole suite of things. And we've been using Tarmac now for our main civil supply for, I guess, 1.5 years. And all the stresses and pressures that we always had previously with big pours have gone. We know we're going to get good supply. And to be honest, we have a little WhatsApp group now. We've been running that since day one. We're told things, if there's any issues, we're told up front, and we're told when they're going to be put right. And there's not a lot, it's very rare. But the worst thing you want is misinformation, and we've never had that. And I say it's very, very rare that we have any issues, and if we are, we're told straight away. And we're also told when they're going to be put right. Yeah, I mean, the whole thing about this full round shutter is like a tin can suspended inside a tunnel. And so you're pouring concrete around that tin can. And the last thing you want is a cold joint. So once you start, you've got to be certain you can finish it. And then logistically, pumping up to 300 meters as well. So you need to have several trucks that are the right consistency, and you're ready to go. You don't want to be starting and then wondering if the next truck is going to be engaged for what you want. You don't want to be rejecting it once you've started to pour. So a lot of the lab trials were to look at the retention of the fluidity. We wanted 4 hours. We figured it would be at least up to about 2.5 hours from starting to finishing. So we need a little bit of contingency in there. That's why we went for the 4 hours workability on it. And the mix was developed in the lab, and saw the graphs, and that gave us a little bit of rattle room for traffic and expected issues. And we did need that occasionally with traffic in London, but we've never started a pour that we couldn't finish. There's 49 separate pours in total using that shutter. So the other thing we wanted to do with the full-scale pumping trials was to see, I mean, this concrete is fibre reinforced. It's got 40 kilograms per metre of fibres. The fibres are not easy to pump. Any undulations on your pump line, they get blocked up. They can get blocked up in the grill leading into the pump. So it's very important that you trial not only the concrete, but also the way you're going to pump it. The pump line that you're using, the joints on the pump line, you need to know that these fibers are not going to get blocked there, because that's the last thing you want, is a blockage. So we mimicked on our trial, we did this out in Heathrow, we set 300 meters of pump line up. We did flow tests before we started pumping at the pump, and we did flow tests at the discharge point to check that we had that. We also mimicked what the invert section of the shutter would look like with a £100,000 bespoke testing rig from the shutter supplier. One of the main issues we had on the lead tunnel was the quality of finish, and the invert was poor. We had to do a lot of remedials. So we were heavily focused on getting that invert panel right. We wanted to make sure that the pumping process didn't deteriorate the concrete, give us a poor finish in the invert. We did up to 12 test pours in total to be certain that the concrete was what we wanted. And then we could go forward with confidence. There's always still an element of doubt until you do the real thing. But we've had minimal remedial work at Hammersmith on the secondary lining. Only what you would expect on any concrete pour, you do little snots and things like that. But in terms of any pore holes or voids in the pour, we haven't had any of that at all. And we struck the shutter in the time we needed. As I say, we did a pour every day on the nose. It was 1 o'clock every day. When you can pour concrete consistently like that and rely on the quality of the supply, makes everyone relaxed, including the lads on the shutter. They know that concrete's going to turn up, it's going to be good quality. They haven't got to worry about that. So it just makes the process and production much smoother. And people like myself can relax and focus on other things rather than having to chase concrete and mix designs and every day having to ask, is it engaged, this concrete, is it in the flow? Your energy goes on to other areas because you know it's got to be right. And that's so important. And I've said as well, if I had any problems, if it was minimal, I knew I could phone Chris up, bypass everything else, and I knew Chris was on it straight away. And in my position, that's so powerful and reassuring. So, yeah, it's been good. In the early days of projects, commercial things drive things, and people are always looking for the bottom price, the lowest price. But look at the batcher and the people who are running it, I think is so important. And I mean, I visited the batcher because I wanted to make sure you knew how this was to me to get this concrete right. I'd had a lot of issues previously. I wanted to be sure we weren't going to have them again, the lead tunnel. So yeah, and to see the people and to see how well I was treated. You're right. Everyone could see this just wasn't. We weren't just running through the standard tick sheet. This really had to happen. You're right. So yeah, definitely, it's crucial. You've no idea how difficult concrete pours were here before you got involved. Every big pour we were on edge, and several of them went wrong as well. I mean, I'm not just talking about tunnel secondary lining here. And the response I was getting to my concerns was, I just never felt I was talking to the right person. Mm-hmm. So such a pleasure to just know that you were there, Chris. You were the right person. I know it sounds corny, but it's made a huge difference to Hammersmith performance.
My name's Ben Howard. I'm a contracts manager for Tarmac Contracting, working in sort of southeastern Anglia.
And what contract are you currently involved with?
I'm currently working on the A11, which is a job for Area 6 Highways England, which